Dear students, so this is after certain interval. I hope you are doing fine, all of you. Now today's topic is something which is of very significant importance. That is what we call modulus or absolute value function. Now from very junior level to something very intermediate and senior level, this is one of the most important topic in number system, lateral number theory, in calculus, in algebra, in combinatorics, and anywhere. I mean, it's of utter importance. So I welcome you all to our channel. So just settle down. So we are having a very brief but very fascinating journey of modulus or absolute value function, which is a part of IOQM also, and in foundation course or those who are in class 11, it is important and it is suitable for all of you. So basically, what is absolute value function? Absolute value function is it is denoted as y equals to modulus of x. This parallel bar, it is what we call mod x. Y equals to mod x. Now basically it is something like a machine where your x is the input while y is the output, and there is a process chamber actually, and that is the rule. So mod x basically gives x provided x greater than equals to 0. It gives minus x when x less than 0. Now that means if, for example, you have mod 5, so what is the value of x here? 5, and 5 is greater than 0. So within these two, this should be the case. That means mod 5 is 5. For mod of minus 5, now x equals to minus 5. That is negative. So whenever it is negative, that means there is a minus sign accompanied with the value of x. So what is x? Minus 5. So that's how modulus is operating. That means modulus or absolute value function is always giving the positive output. Whatever be the thing, it will give you positive output under this condition. Now these two are mutually independent. I mean, x greater than equals to 0. If somebody is asking you what is x greater than equals to 0, that means either x greater than 0 or x equals to 0. That's how it goes. So for a or b belongs to real number set, a greater than equals to b, that is also either a equals to b or a greater than b. Now let's try to deal with graphically a pure graph, y equals to mod x. So let's have a paging over here. So if x is 0, y is 0. If x is 1, y is 1. If x is minus 1, y is plus 1. If x is 2, y is 2. If x is minus 2, y is plus 2. That's how it goes. So somehow if this is the case, 1, 2, 1, 2, minus 1, minus 2, minus 1, minus 2, then x is 0, 0 is this point, 1, 1 is this point, minus 1, 1 is this point, 2 and 2 is this point, minus 2 and minus 2 is this point. So if you join the line, this line gives you y equals to x, this line gives you y equals to minus x. That means what we are getting, that if above the origin is taken as positive and below the origin is taken as negative, so somehow nothing in this graph is visible below y, below origin. So that means it is clearly visible that all the output, it is always positive. But x can be positive as well as negative, including 0. So x can be any real number. So domain of the function is all real number, while range of the function is restricted between 0, which is in third bracket, and plus infinity. As infinity is always open, so it is usually first bracket. So that's how we are simply going to get the modulus part of it graphically. Now this can also be done in a reflection method in x-axis. Let's see how we can deal with it. Just a minute. So y equals to mod x, somehow it is very important thing. Whenever you are going to unfold modulus operator, it will give you either plus x or minus x. So this is the line which is y equals to x, and this is the line which y equals to minus x. Very simple. Y equals to x is resembling with y equals to mx, and m equals to 1 over here. So somehow this angle is 45 degree, while this angle for m equals to minus 1, theta equals to 45 degree or theta equals to 135 degree as an angle of inclination. But as you see that all this portion is below the origin. Now if this is x-axis and we imagine it as a plane mirror, we just reflect this line in this x dash axis, so that this line is typically superimposed with this line, and this line is getting reflected here, this line. So y equals to x and y equals to minus x can also be visible in that fashion also. So that's how it goes. So one important thing, that is mod x is not plus minus x, it is false. Mod x equals to either plus x or minus x. That's how it goes. So I hope these are very basics. So there are a couple of very short videos that we are coming up with it, and with 4 to 5 minutes video. This is a mini series: modulus, basics, domain, range, then the properties, then some basic application, modulus equation, then something more, how we are going to implement it in composite function, everything, and some PY2 for IOQM as well as pre-RMO in depth, where modulus is really getting heavy for some JEE main also. So this is again one of the classic series that will continue. It is within the part of IOQM and foundation, so we are just navigating as much as domain that is possible. I hope you are liking the video as usual. So if you do have any queries, please don't just forget to bother me. I mean, it's something, not a matter of botheration. You can ask anything anywhere in this WhatsApp number, but that is getting reflected in the description link. Just stay focused and be in good health. God bless. Thank you.